So first of all, thanks everyone for joining on a weekend, and welcome to the two-day session on deployment strategies. So my name is Adam, and what is that we're going to do in this session today and tomorrow, right? So before we understand, for those who are new, would request and recommend you to go ahead and subscribe and like our channel, and you'll be getting a lot of videos like this in the future. So what's the agenda? As I was just trying to start, you might have been hearing a lot in DevOps that you deploy applications, right? So deployment is not just, okay, you run some applications, especially in the modernized world, we are not doing the traditional deployment, but we are using more of container-based deployments. So when you do a deployment, we need to understand what kind of strategy that we have to follow. And again, before we say what kind of strategy, first of all, we need to understand what is the need of a deployment strategy. So that's the very first thing that we have to understand. And then we'll also try to understand what are the different types of strategies available. And with the help of that, you need to make an analysis of what is the type of application you have and which strategy fits your business need, right? Because we have stateless application, stateful applications. So we need to understand both of them. So that's the whole purpose. And we are not going to just talk only about the theory or manual way of doing, but that's when tomorrow we will try to do more of a continuous deployment where whatever the strategy we are learning today, we will try to automate the same. Okay. So again, before I start with what is a deployment strategy, let us just make sure ourselves we are clear on what exactly is a deployment or a software deployment. So ideally, what happens when an application is given to you, right? So I'm assuming something like a web application. So if it has to be used by some person like a dev or a QA or someone on the user acceptance testing or a customer. So we need to run that application on a particular machine or group of machines, right? But that's not as simple as what we think. But this is where a software deployment is all about the process in which we make sure that application is running on all the machines that you want, which includes you need to first install that application, whether it's a jar or a var or you have a tar file, regardless of what kind of application. You need to first install it on all the machine. And then what is that you have to do is you need to configure the machine. Right? What is that you mean by configuring? Now, your application, let's say a web application, when you try to run it on a QA machine, it needs to communicate to a QA database. The same application, if you try to install it on a production machine, for a customer to access, it needs to connect to a production database. So this is where the application is same, but we need to configure the application in such a way it connects or communicates to other services for the application to work. And eventually, the steps doesn't only stop with installing and configuring, and then you need to start and run the application. And only when the application is successfully running, you can go ahead and use. So this is what happens whether we are using our application for our development purpose or for various testing purpose or for the end client for whom we put it into a machine or machines called as production. So ideally, this is what we call it as a software deployment, okay, or an application deployment. So application deployment is all about taking our application, which is a binary or an artifact, install it on a particular machine of our choice, configure it so that it can connect to whatever the other services like database it is needed, and then we start and run the application. Only when all these happens, a person or a user can access the application. So that could be a developer, or that could be a QA, or it could be someone like us whom a customer is going to access on the production. Now, this process is called as software deployment. And this is when, to understand it better, let's take a web application. Let's assume that I have my own web application or a website, right, like Wezva.com. So now, let's say this is a Java-based web application. So what and all is needed for me to say that my application is deployed? Now, installing is where we are not going to talk only about your jar or var in Java, but along with that, what are the other things necessary for your application to run, right? So that's where if you take an environment like a QA or a production, for me, a web application, which is a Java based, if I want to deploy, ideally what it means is I need to have a particular OS with some libraries. And then since I said it's a Java based application, then I might need some specific version of JDK. And then if this is going to depend on some application server like Tomcat or JBoss, then I need to install that also. And after that, you're going to install your jar or var, and then whatever the certificates that is needed for your application, as well as the configuration files that is needed. So you're going to put all these things, plus you also have to make sure that there is some kind of script which is written, which could be a shell script or a Python script, okay, which will be used to start your application. So this is when now deployment means on a given machine, you make sure everything is installed, configured, and then by starting or running this script, your application will also be started or running, which is when we call it as deployment. Okay, but this is where in the modern way of deployment, we started using more of container-based deployment, because instead of we taking machine and installing all these things and configuring, which is going to be a time-consuming process, as well as it is prone to error and it is not scalable. So which is where the more modern way of deploying is through containerization. And that's where if you want to deploy this as a container, then we need to make sure you have a proper image, like a Docker image, in which you put all those which are common to all the environment, and anything that is specific to an environment, you will be injecting it into your containers during runtime. So I'm not talking more about Kubernetes here, but it's more, for example, in Kubernetes, you take an image and try to create a pod or a container. So that will have only the common environment. Whereas from application, if it needs a certificate or a configurations, then you are going to inject it using separate objects like config map or secret during the runtime, because you will not have a config file common for all the environment, right? So this is how right now the modern way of deployment is by taking a Docker image where you have everything pre-installed, pre-configured. You're just going to take the necessary files and create a container which is replacing your environment. Okay, so as of now, what exactly is deployment? Creating a container which has all the necessary things pre-installed and pre-configured, so that as soon as the container starts, we also know the basics, right? So when you start a container, what happens? Every image will have a default startup command. So that's where you can mention these kind of scripts to put as the startup command. So that way, for us, deployment is all about creating a container, okay, which internally has everything pre-installed, pre-configured, and automatically creating a container starts your application. And that's where, as of now, replacing your traditional way of deployment, creating a container by injecting all the necessary files is what we call it as a software deployment. Okay. However, now if I come back to the point, in real time, creating a container is not going to be just with one container, because we will require multiple replicas And this is where, again, go back to the basics. So why do we need multiple replicas? For resilience and high availability, so that if one container goes down, you always have another container for load balancing. And when the requirement is you have multiple containers across multiple machines, and that's where we will start using an orchestration tool. But the whole point now comes is for a dev or a QA or a customer to use your application, now you have to create a container or multiple containers across multiple machines. So that's when we need to know what exactly is a strategy we have to apply. Okay. So now deployment strategy is nothing but a technique in which there might be something already running, a container and an application. Now you want to change that container with a new container, or upgrade your old container with a new container. Because what people doesn't think about is you're not just going to create a container and leave it, right? Go back to your day-to-day life. The Facebook, Google, LinkedIn, all your bank sites. That's an application that you're accessing, right? But on the back end, if you look, everything is running as a container in some production machines. So a company keeps on developing products, or same product, they will be doing new releases, which is what we call it as new versions. Now they have to replace or upgrade the existing one with newer version of the application, right? So in that case, what happens? You're not talking about just creating a container. There are multiple replicas of your container which are running on different machines in the cluster. You need to replace that with the new version, correct? So that's what ideally we call it as a release. So now for us, we need to understand we have to follow some kind of technique which helps us to replace all the older versions of our pod from one build to another build, which is the latest version. So such a kind of technique is what we call it as deployment strategy. Why do we need it? Because from a business point, if you look, we need to do, there is a zero downtime, especially let's talk about your Facebook or banking website. Do you think that they are not doing any upgrade? There will be very frequent upgrades that they will be doing. So let's assume that they are doing a release and an update every week. So are they saying, okay, Facebook at this time, every day or every week will not be available, or your banking site will not be available, right? They never do it. So that's what we call it as zero downtime. They have to upgrade, which is nothing but they have to replace their old replica with new replica, but that shouldn't be causing a service issue, or that shouldn't cause a problem to the customers in accessing. So we should continuously access, but at the same time, on the back end, they should be changing the older replicas with newer replicas, or old pod with new pod, or old container with new container. Wherein, when I say old container, old image with new image. Okay, getting it? So that's where companies needs to do zero downtime in deployment. So it is not just that, oh, I will go ahead and deploy, but what I have to do is I need to make sure when I am replacing my old versions of my container with new pod or container, I should not be causing a problem to the customer. How are you going to do? So that's where strategy comes in. So you can't just blindly say kubectl apply or Docker run and create a container. Okay. The next thing is reduce time to market. Now, the challenge with the current market is there's a lot of needs. So development is going to happen continuously. Testing will happen continuously, and they have to deliver continuously. That's where the DevOps concepts are being very popular, right? So now they can't wait for a longer time to say that your release will happen and we will be trying to change the old version to new version. So it has to happen in a shorter period of time. So that's when your customers will be happy, right? So Next, faster rollback. What do you mean by rollback? It doesn't mean every time when you change your older application with a new version of the application, everything will work fine. There could be various reasons for which it is not running. Then what should we do? Immediately we will switch back to the older version or the old containers or the image which was working perfectly fine. And this is where I'm talking not just about one or two containers. You might be having hundreds of containers, right? So in the production, when customers are accessing, if something goes wrong, you should be able to easily switch it back so that it doesn't cause problem to your service or to your business. So that's again necessary, which is where strategy comes in. And finally, you need the ability to do it again and again and again, because the market is in such a way. There are companies who also do releases very frequently, in once in 2 days or 3 days or in 1 week. So whatever the steps that you have done, it's not just like one time that you have to manually do, but you need to have an ability that you can do it again and again, no matter how many times I want. So that's how, as an organization, you will have the ability to keep on doing releases on need basis, and without causing much interruption to your services, you can also do the deployment. So development will happen, testing will happen, and at the same time, deployments will happen. Okay. And that's why it's quite important for us being a DevOps engineer to also understand what kind of strategy that you will follow. As I said, it has to suit your application and business need. And this is where in the deployment strategies, there are various types of deployments, but ideally in the market, what you would see is 4 types of deployments. Okay. Now, let me just give you a brief, but then let's go into detailed one by one. So the very first method, what we call it as recreate. Okay. So I want you guys to just remember this word, which will be easy. So recreate means whatever you have, just terminate it and then create it with new one. That's called as recreate. Okay. The second one is what we call it as the rolling update. Okay. So what is rolling update? So rolling update means, for example, if you have one replica, unlike the recreate method, you're not going to delete it. First, for one replica, you create a new container based on the new image. And once this new container is successfully up, then corresponding to that, whatever you had the old one, you are going to remove it. Okay. So this way, if I have 5 containers which is running on old image, then you will first create the first container based on new image. And once the first new container comes up, you will delete one old one. Then you will create the next new container. So that way you are going to do one by one. So for every new container that is successfully up, you are going to delete one old container. So that's what we call it as rolling update. Okay. Then there's a method called BlueGreen. So what is BlueGreen? Now, this is also called as zero downtime. Okay. Now, when we are trying to do the other methods, what will happen? There will be some kind of disruption in the service, because definitely you have to stop your service, which we will see. Okay. So this is where in companies, they want to say, I want to change my older version to new version without causing even 1% of impact. So for that, what we'll have to do is, you do not touch the existing containers. So while the existing containers are still running, you will create new containers from new image. And only when all the new containers are successfully up, you are going to just switch the traffic from the old containers to the new containers. Okay. So that's what we call it as BlueGreen. So the word that I want you to understand in BlueGreen is, you will have 2 sets of your containers running, and all you will do is switch. But you are not going to do anything like create one container and delete one container. Okay. So Just to quickly give you an idea, recreate means you first delete everything and then create. Rolling update means for every single replica, you create a new replica and delete the old one. Whereas in a BlueGreen, you do not do any deletion. You just create another new set of containers and then we will switch. Okay. And finally, the other popular method that we have is Canary. So once again, in Canary, we are not going to again create all the containers necessary, but I want you to remember this word which is called as percentage basis. So now you are going to decide when you say that my old version of container has to be replaced with new version, how much of percentage that I am going to start with, which means you will decide on a set of users or a percentage only for which you will be doing the deployment with the latest one. So you validate and then you proceed with the remaining. Okay, so just this 4 words. Recreate means delete and create. Rolling update means delete, it's not delete actually, create and delete, but one by one. Blue-green means you just create everything together, then switch the traffic. And Canary means percentage. So if I have 4 containers and I want to replace, and if I say 25% is my need, then 1 container at a time. So that's how. If I say 50% is my need, 2 containers. So that way, think of this as a percentage, right? Just remember this much. Okay. Now, why we are talking about this now, especially when we say deploying in container, now we know that there will be multiple containers or replicas against multiple machine, which is where we will be using an orchestration tool like Kubernetes, right? But Kubernetes supports only 2 types of deployments, which is recreate, or recreate is also called as Big Bang because you just delete and start. And the other one is rolling update. Okay. By default, if you do not tell any strategy to Kubernetes, it will always work on the rolling update. So all those things, what you have learned and you have practiced so far, what is the default strategy? Rolling update, remember. But there are 2 more strategies as I have put here called Blue, Green, and Canary. Is not something Kubernetes gives us straightforward. So using this rolling update, we have to do a further customization on top of it. It's like we have to handle it. Okay. And we need to achieve. So that way, remember, Kubernetes gives only recreate and rolling update. But we need to understand how we can do it on top of your rolling update. Okay.